everybody. In this video, we're going to be talking about combinations, which are related to permutations. So take 3 deep breaths and let's make this math easy. All right, so let's say that we were going to choose 2 friends to go on a trip from a group of 4 friends. So the way that we could start solving this problem is pretty much the same that we would start when we were solving the permutation problem. Because we would say, okay, well, my choice tree is going to start off with 4 different branches, and then each of those branches are going to branch off into 3 different branches. Because if, let's say I choose friend A, well, if I choose friend A as my first friend, then I can't choose friend A as my second friend, but I could choose B, C, or D. And same thing if I chose B as my first friend, or C or D. So I actually wrote this diagram out in advance. So this choice tree is just kind of turned sideways so it fits on the slide better. And if you look at this choice tree, you'll notice that the number of options in the choice tree is 4 choices for the first choice times 3 choices for the second choice, which means that we have a total of 12 different options in this choice tree. However, the thing that makes a combination different from a permutation is the fact that the order doesn't matter. So if we look at this choice tree, we can see that one of the possibilities is to choose friend A and then choose friend B. But that is a duplicate of choosing friend B and then choosing friend A. Because it doesn't matter which one you choose first. They're both going to go on the trip. And so that's a duplicate. We also have other duplicates. Like, for example, we have the duplicate C and B is the same as B and C. And so that's another duplicate. And basically, any one of these options in the choice tree is going to be duplicated if the order doesn't matter. And so the way that we calculate that is we say, okay, well, there's 12 possible options in the tree, but all of the options are duplicated twice. So to find the number of ways to choose 2 friends to go on the trip, I would need to divide by the number of duplicates, which in this case is 2. And so that tells me that there's 6 unique ways to choose 2 friends to go on a trip with. And we could list these 6 ways out if we wanted to. So we could say, well, I could choose friend A and B, or A and C, or A and D. Or I could do B and C, and I skipped B and A because I already listed it. And then B and D would be another choice, or C and D. And you might notice that this pattern is very similar to the pattern that we used with Copeland's method when we were doing voting theory, because Copeland's method basically had us choose pairs from all of our different options and do the pairwise comparison. So essentially, we were actually doing combinations with Copeland's method. We just didn't call it that. So these would be the 6 different options. And I want to point out how permutations are different than combinations. Because permutations, they start off the same way. You just don't divide by the duplicates. And the reason for that is because permutations are used in situations where the order does matter. So let's say that instead of choosing 2 friends to go on a trip from this group of 4 friends, maybe you were choosing a president and a vice president. Well, if you were doing that, then it does make a difference whether you choose person C and then B, or if you choose B then C. Because if the first choice is your president choice and the second one is your vice president choice, it is different if you have C as your president and B as your vice president versus having B as your president and C as your vice president. And so the only difference between combinations and permutations is whether or not the order that you make your choices in matters. If it does matter, then you use a permutation and you don't divide by the duplicates. If it's a combination, that's going to be when the order doesn't matter. Like in this case, choosing 2 friends to go on a trip. It doesn't matter who you choose first and second and third. They still all get to go on the trip. In that case, then you do divide by the number of duplicates within the choice tree. So let's do a slightly harder problem where we're choosing 3 friends to go on a trip from a group of 4 friends. So it's very similar to the one we just did, except that we're choosing 3 friends instead of 2 friends. So the way that you would calculate the number of options in this choice tree is you would say, well, there's 4 choices for the first friend that you choose, so I'll do a 4. Then each of those branches off into 3 choices, and so I'm going to multiply 4 by 3. And then each one of those branches off into 2 choices. And so I'm going to multiply by 2. And if this was a permutation, I would be done at this point. I'd just calculate out what 4 times 3 times 2 is, and that would be the number of ways that I could maybe choose like a president, a vice president, and a secretary. But because it doesn't matter who I choose first or second or third, they all get to go on the trip, and it's all the same regardless of who you choose first, second, and third, then I need to divide by the number of duplicates that I have. So I'm going to look at how many duplicates there are of the combination A, B, and C. So there's one of them, but I could also have A, C, and B. That's basically the same combination. I could have B, A, and C, or I could have B, C, and A, or I could have C, A, and B, or C, B, and A. And that last little section of the tree won't have anything because that has option D, and I'm just looking at the duplicates of A, B, C. And so if I look at this, I have 1, 2, 3, 4, 5, 6 duplicates, and so I need to divide the number of branches in my tree by 6. Because this was just one combination, but if I chose another combination like, I don't know, D, B, A, well, there's also going to be 6 of those because I could have DBA, or I could have DAB, or I could have BDA, or BAD, or ADB, or ABD. Any of those would work. And if you notice, there's 1, 2, 3, 4, 5, 6 of those as well. And these other ones that I haven't done yet, they would also have 6 duplicates. And so to calculate the number of unique ways that you could choose 3 friends to go on a trip from a group of 4 friends, you would just say, well, 4 times 3 is 12, times 2 is 24. Do 24 divided by 6, and that would give you a total of 4 different ways that you could choose 3 friends to go on the trip with you. And those would be the number of unique ways where the order doesn't matter. So you might be wondering, okay, well, how do you find out what this number is? Like in the last 2 examples, we actually just counted how many duplicates there are. But if you have a ginormous choice tree, you don't want to have to go through and draw the choice tree for one thing, and then you also don't want to have to go through and count the number of duplicates. So there's got to be an easier way to calculate this. And the way that you calculate that is based on how many things you're choosing. So in this case, I chose 3 friends to go on the trip, and the number of duplicates is going to be the number of ways that I could arrange those 3 friends. Because essentially what this choice tree is doing is it's giving me all of the different arrangements of 3 people. And the number of ways that I could arrange 3 friends is going to be 3 choices for the first person in the arrangement, 2 choices for the second person in the arrangement, and 1 choice for the last person in the arrangement. And you'll notice that that does equal 6. And if we go back to this example, you can also do the same thing with 2, because the number of ways that I could arrange 2 friends would be 2 times 1, which does equal this number of duplicates. So basically, the number of duplicates that you have is going to be the number of people you're choosing, and you're going to multiply it down until you get to 1. So let's do another example of this. So let's say that we were building a committee of 4 people from a group of 10 people. Well, if we were to draw a choice tree for this, it would be huge. But we know that the number of options in the choice tree is going to be 10 times 9 times 8 times 7. Because for the first choice of who's going to be on the committee, there's 10 different branches of the choice tree. Then each of those will branch off into 9 branches, because whoever you chose as your first committee member can't be on the committee again because they're already on it. So you'd have 9 choices for the second person, then 8 choices for the third, and 7 choices for the last person on the committee. So this would be the number of branches in the choice tree. But because a committee of 4 people isn't specified as like a president, a vice president, or whatever, and all 4 people will be on the committee regardless of which order you choose it in, the way to find the number of unique ways that you could form this committee is to divide by 4 times 3 times 2 times 1, because that's the number of duplicates you'll have in this choice tree. And again, that's because this describes the number of ways that you could arrange any particular group of 4 people. And a lot of times this notation, rather than actually writing it out, we use a notation that's called a factorial to represent this calculation. So this calculation can be written as 4 exclamation mark, and that basically equals this calculation here. But it can be helpful if you're like trying to do like 16 factorial, like rather than having to write out 16 times 15 times 14 times 13 times 12, like all the way down to 1, you can just write it as a factorial instead. So that's just a notation piece. So to calculate out the number of ways that I could choose a committee of 4 people, I would do 10 times 9 times 8 times 7, which gives me the number 5,040. And then I divide that by 4 times 3 times 2 times 1, which is 24. And 5,040 divided by 24 is 210. And so there's 210 ways that you could choose a committee of 4 people from a group of 10 people. And that's how you calculate combinations. If you have any questions, let me know.